Hi, eighth grade again. This is your little crash course on chemical equations and how to balance them. This type of setup should be a little familiar from you for seventh grade, where we have a chemical equation. So on this side of the equation here, are the reactants, right? So the atoms or molecules that are reacting together. And over here on this side is the products, right? So it kind of looks like a math equation, which it is. It's a math equation for atoms and molecules. So now the law of conservation of matter states that matter can neither be created nor destroyed, but transferred from one form to the other, right? So you can't make matter from nothing, right? I can't make oxygen from nothing. We all watched The Martian. He had to make water from something. So when you look at a chemical equation like this, the two sides have to be balanced, right? So if there's two hydrogens right here, so H2, meaning we have two hydrogens, there has to be two hydrogens over here, right? H2. So hydrogen plus oxygen gives you water. Now, you might see a problem with this. Here we have two oxygens, but we only have one oxygen over here. Where did that other oxygen go? Disappeared. No. So what we have to do is we have to balance this equation. So this side is equal to this side. So what we're going to do here is you look at what's missing, right? So here we have two oxygens, but here there's only one oxygen. So I can put a number in front of here, like 2, okay? So now this says I have two oxygens, but this 2 applies to the whole molecule, right? So now I have 2 times 2, I have 4 hydrogens, right? But here I only have 2 hydrogens, right? So what I can do is I can put another 2 in front of here, right? So now I can look at this. So 2 times 2 is 4. I have 4 hydrogens. I have 2 oxygens. Here, 2 times 2 is 4. I have 4 hydrogens. And if you don't see a number next to it, right, you just assume that's 1. So I have 2 times 1, I have 2 oxygens, right? So now it is balanced, right? So what this means is that I have 2 molecules of hydrogen, or 4 of gas, so 4 hydrogen atoms, right, with 1 molecule of oxygen or 2 oxygen atoms gives me 2 molecules of water, right? And this is how we balance chemical equations. This is very useful when you're running different experiments, things like that. You're trying to get product. You want to try to figure out how much reagent you need, how much product you want to get. You can actually start to calculating out. These are actually called moles. That's a fancy word you're going to come across again in sophomore year chemistry. And then you can use moles and convert them to grams and mass, and you can start figuring out how much of this you need to make how much of that. All right. So I'm going to do a couple more examples for you. Okay, this one is, I have a blank here. So we're going to figure it out. So this is saying carbon monoxide, CO, plus water gives us hydrogen plus something. And this something is a gas, right? Now I'm going to give you a little hint here. Whenever you see a gas, right, let's look at here. So I have a carbon over here, but I don't have a carbon over here, right? So I know this gas has to have some sort of carbon in it. What's a very common gas that has carbon in it? It's one that's causing us lots of problems right now in terms of global warming. Okay, that's enough of a dramatic pause. It's carbon dioxide, so CO. Okay, so carbon monoxide plus water gives you hydrogen and carbon dioxide. Good job, Miss Sense. You spelled it right. That's a win in my book. All right, so let's see if this is balanced. Let's check it. So we have 1 carbon on this side, 1 carbon on this side. I have 2 hydrogens on this side. I have 2 hydrogens on this side. I have 2 oxygens on this side, and I have 2 oxygens on this side. Okay, so I don't have to do anything to it. It's already balanced. So 1 molecular mole of carbon monoxide plus 1 molecular mole of water gives you 1 molecular mole of hydrogen gas and 1 molecular mole of carbon dioxide. All right. Now, I find these ridiculously fun because I'm a big nerd. They're like puzzles. They're like Sudoku puzzles for me. I just could do these all day. So we're going to do just a couple more as practice together. Right, so here we have sulfuric acid, H2SO3, and with some energy, that'll break down into sulfur dioxide and water. Okay, so let's look at this. So do we need to do anything to this? So let's start with hydrogen. I have 2 hydrogens here, and I have 2 hydrogens here. Right? I have 1 sulfur atom here, and I have 1 sulfur atom here. I have 3 oxygens here, and I have 2 oxygens plus 1 oxygen is 3 oxygens. So again, this is balanced. I don't have to do anything to it. I have the same number of hydrogens on each side. I have the same number of sulfur atoms on each side, and I have the same number of oxygens, 3 and 3. So that one's great. All right, let's take a look at this one. Potassium plus boric oxide, B2O3, gives us potassium oxide plus boron. All right, so right away I can see there are some issues here. So let's look at this potassium. So I have 2 potassiums here. I only have 1 potassium here. So right away I know I need to try to fix that. You know, and sometimes you go back and forth and back and forth. I'm not giving you any super crazy hard ones because this is brand new and this is actually sophomore year chemistry. But you are all very smart people, so you can totally do this. But I'm not throwing any crazy ones at you. Anyways, so now I have 2 potassiums, 2 potassiums. Great. All right, borons. Here I have 2 borons, but over here I only have 1 boron. So let's stick that 2 right over here. So now I have 2 borons, 2 borons. All right. Here I have 3 oxygens. But here I only have 1 oxygen, right? So what can we do to fix that? All right, so what I can do is if I know I have 3 oxygens here, I can go ahead and put a 3 right here for 3 oxygens there. Now, you'll see there's something I need to fix, right? So I have 2 borons, I have 3 oxygens, but now I have 3 times 2, I have 6 potassiums. So that's easy. I can just go back to here and change that to a 6. All right, so let's check it. 6 potassiums, 3 times 2 is 6, and 6 potassiums. 2 borons, 2 borons. 3 oxygens, 3 times 1, remember this is a 1, 3 oxygens. Okay, now we're balanced. All right, let's go to the next one. So this is adamante plus chlorine gas gives you carbon plus hydrochloric acid. All right, so this one was a little trickier one, so I started out with this right here. If you want to pause this video and if you want to try to do it yourself to see before I go through it, that's great. You should absolutely 100% do that. All right, so let's look at this. So right here I have 8 times 2, which is 16. All right, so I have 16 chlorines. So I'm going to put 16 right here, and let me just gives me a little extra room. Okay, 16 here. All right, now I have 16 hydrogens, and here I have 16 hydrogens, right? Now I have 10 carbons, so let's stick a 10 right here. All right, let's see. Did we do it? Does it work? Let's check. Okay, so 10 carbons, 10 carbons, 16 hydrogens, 16 hydrogens. 8 times 2 is 16, 16 chlorines, 16 chlorines. Boom, we're balanced. Okay, last one. Glucose, C6H12O6, plus oxygen, O2, gives you carbon dioxide and water, right? So this is basically our metabolisms right here. We take glucose with oxygen, with a teeny bit of energy here. We get carbon dioxide and water and a lot of energy over here. So this is going on in our cells all the time. Okay, now, ready? Let's see if we are balanced. Again, if you want to pause this and try to do this yourself, and then you can unpause it and check my answer with me. Okay, so let's look here, C6. So we know we have 6 carbons on this side. So let's put 6 carbons on this side. All right, so we have 6 carbons on this side. Right, now we know we have 12 hydrogens on this side. We only have 2 hydrogens on this side. So we can go ahead and add another 6 here, right? Okay, so carbons are looking good. 6 carbons, 6 carbons. 12 hydrogens, 12 hydrogens. Okay, now let's look at the oxygens. So right now we have 6 times 2 is 12 oxygens. And then we also have another 6 oxygens. So we have 18 oxygens on this side, right? But on this side, we only have 8 oxygens. So we need to fix this. So if we add another 6 here, right? So we have 6 times 2 is 12, plus another 6 is 18, right? So we have 6 carbons, 12 hydrogens. 6 times 2 is 12 hydrogens. We have 6 times 2 is 12 oxygens, plus another 6. 12 plus 6 is 18. And then we have 6 times 2 is 12, plus another 6 over here is 18. So in your body, when your cells are breaking down sugar, your cells take 1 sugar molecule, glucose, with 6 molecules or moles of oxygen to release 6 moles of carbon dioxide and 6 moles of water. There you go. I hope this makes sense. I hope it's somewhat fun for you. Do your best. This is advanced stuff, but again, I think you can handle it.